Hi, welcome back to the final exam review, examples part C. This time we're going to look at the B versions of each questions and see if we can use the A versions to help us know how to do the problems. All right, so what is the area of the given trapezoid? They're both trapezoids, which means they're both going to use the same formula. So I don't need to go look at my formula sheet if I have my review. 1/2 B1 plus B2 times the height. So my area equals 1/2, my two bases are 13 and 8 here, so here, 16 and 31. My height here was 4, so my height here is 5. And then I'm ready to go to the calculator. Area equals 1 divided by 2 times 16 plus 31 times 5. 117.5. My units here are meters and its area, so squared. All right, there is 1B. Let's look at 2B. If the measure of arc EGF is 235 degrees, find the area of the shaded sector. Okay, if I look at the formula that I used on the last one, the measure of the arc over 360 times pi r squared. Okay, look at the measure of the arc, the measure of EGF. That means I start at E, I end at F, and I go through G. So they didn't actually give me the arc that I'm looking for. They gave me this outside arc. So it's a little going to be different than this one because I need to know what's the shaded arc, right? I know there's 360 degrees in the whole circle. I've used 235 on the arc I'm not interested in. So 360 minus 235 tells me that what's left for this side is 125. So 125 over 360 times pi r squared. My radius is 20 squared. 125 divided by 360 times 20 squared gives me, let's see if I can make that into a fraction, because that's not a pretty decimal. Nope, it won't. So I'm going to be stuck here. It's going to be 3472.2 repeating pi for my exact answer, because I did note that it was repeating, square inches. My approximate answer times pi, rounded to 3 decimal places, 308. So 10,908.308 square inches. And again, I didn't have to go look up that formula because I have my review problems. So again, having that review handy is really helpful when you're doing your practice test and your final exam. The radius of a sphere is 8 inches. Find the surface area to the nearest hundredth. So surface area of a sphere, here I had to the nearest tenth. This is to the nearest hundredth, so that's just one more place. My surface area equals 4 pi r squared. So my surface area is 4 pi. My radius, they did give me my radius this time. It's 8. I don't have to figure out what that is like I did over here. So 4 times 8 squared is 256 pi. And since I want it to round it to the nearest 100th, I am going to multiply in that pi and round to 2 places for the hundredths place, 804.25. My units are square inches. Okay, let's look at 4B. Find the lateral area of the regular pyramid, which is exactly what I was doing over here. So my lateral area, L equals 1/2 PL, capital L equals 1/2 capital P, little l. So my lateral area equals 1/2 capital P, that's the perimeter of the base. So my base in this figure is a regular pentagon, which means all the sides are the same, and they are all 8. So my perimeter is 8 5 times, which is 40. And then my L, my slant height, is 12. So this is ready to go in the calculator. 1/2 times 40 times 12 is 240. So my lateral area of this regular pyramid is 240 square feet. Again, I didn't need to go look at my formula chart because I used my review. Using your review can really help you know exactly what formula to use. Okay, 5B, find the lateral area of the cylinder. Look at 5A, lateral area of the cylinder. So that means my formulas, again, will be the same, and I don't need to go look at that formula chart. My lateral area is 2 pi RH. So my lateral area is 2 pi times my radius, 4, times the height, 7. My exact answer, 2 times 4 times 7, is 56 pi. My approximate answer, 56 times pi, is 175.929. And I don't have units here, so they are both units, and it's area squared for each of these. Okay, let's look at 6B. The volume of a pyramid is 42 cubic centimeters, and the height is 10 centimeters. What is the area of the base? So notice, volume of a pyramid is what they gave me. They also gave me the height, and they're asking me for what's the area of the base. So the two problems are very similar, just different numbers. And on the last one, I wrote the formula, volume equals 1/3 capital BH. Then I replaced the V with 64 because that's what the volume is. I'm going to replace the B with 42 equals 1/3 BH. My height here was 4. My height here is 10. Then I multiplied both sides by 3 to get rid of that 1/3. So I'm going to do that same thing. I'm going to multiply both sides by 3 so that it cancels out this 1/3. And I'm going to get 42 times 3, is 126. Equals B times 10 is all that's left here. So B times 10 is 10B. Then I'm going to just divide both sides by 10. So 126 divided by 10 is 12.6 for my base. So the area of the base is 12.6. These are centimeters, and since it's the area of the base, they are square centimeters. Okay, let's look at 7B. Find the volume of the cone. So I already have my volume formula, volume of a cone. My volume equals 1/3 pi r squared h. My volume equals 1/3 pi. My radius is 4 squared my height. Now in my height for this one, I had to do Pythagorean theorem because they hadn't given me that inside height. But on this one, they already gave it to me. So this one's actually even easier than 7A was because they've already told me that's 9. So my volume equals 1/3 4 squared times 9. I'm going to do that part first without the pi. 1/3 times 4 squared times 9 gives me 48 pi. That's my exact answer, inches cubed, because it's volume. My approximate answer, if I multiply that times pi, gives me 150.796 cubic inches. There you go. Let's look at 8B. The volume of a sphere is 36 pi centimeters cubed. Find the radius. All right, so let's see what we did last time. First, I wrote down the formula for the volume of a sphere. Volume equals 4/3 pi r cubed. All right, then I replaced the V with what the volume is. The V here is 36 pi equals 4/3 pi r cubed. Then I multiplied both sides by the reciprocal of 4/3 so that I could get rid of the 4/3. 3/4, 3/4, so that way that would cancel out. And when I do that, 3/4 times, 3/4 of 36 pi, and I'm just going to do the 36, is 27. So 27 pi equals pi r cubed, because those cancel, the fractions cancel, pi r cubed. Then I divided both sides by pi to get rid of the pi on the r cubed. What's nice is because there's pi's on both sides, it gets rid of all the pi's when I do that, and I'm left with just 27 equals r cubed. To uncube something, look what I did over here to uncube the r. I cube rooted it. And in case I forgot how I did that, I even made myself a little note of how I did that. Math and then number 4. So math and then number 4 is my cube root. And I'm taking the cube root of 27, which is 3. So my radius equals 3. My units here are centimeters cubed on the volume, so my radius is just plain centimeters because it's just a length across the sphere. Okay? All right, number 9b. Winnie asked Molly to pick a card from a standard deck, then replace it 3 times. Each time Molly pulled an ace. What is the theoretical probability that she will pull an ace the 4th time she pulls a card? Now, because she is replacing that card each time, the first 3 that she pulled don't have any effect on it the next time, okay? So now, this 4th time, it's not going to have, the first 3 don't have any effect. So the probability of pulling an ace, which is not affected by the first 3 cards that she's already pulled because she put them back each time. So I need to know how many aces out of the whole deck. So I've already got my standard deck of cards open. There are 1, 2, 3, 4 aces out of 52 playing cards. So 4 aces out of 52 total cards. Let's see if that reduces. 4 divided by 52, math. I want number 1, turn it into a fraction, 1/13. So 1 out of every 13 pulls should be an ace. As a decimal, math, and then times 100, that's going to be a 7.7, let's say, % chance that she's going to pull an ace that 4th time that she pulls a card. Okay, let's look at the last one. I know it says 11b. I think there's some sort of typo here. It should match with 10a. Mr. Fogarasi is holding a bag with 1 red marble, 1 blue marble, and 1 green marble. He asks 3 students to each pick a marble. Whoever picks the green marble will go first. Maggie picks first and gets the black marble. What is the probability Daisy will get the green marble if she picks next? Okay, so here's what we've got going on in this problem. Okay, so we want the probability. What's the probability that first Maggie picked and she got a black marble? So now Daisy's going to pick, and what's the probability that on the second pick she's going to get a green marble? Okay, so let's see, the probability that we get a black marble. Okay, actually I think there's a typo here. Let's change this to blue marble. That way we can do this problem because there's no black marbles in her bag, so she couldn't have gotten a black marble. Let's change this to blue, typo there. So I'm going to erase this and change it to blue. Okay, so the probability that Maggie gets a blue marble and then the Daisy gets a green marble. So there's 1 blue marble in the bag out of 1 red marble, 1 blue marble, 1 green marble. So there are 3 marbles in the bag. Okay, times, now Daisy's going to pick next and we want a green marble. there's one green marble still in the bag out of how many marbles in the bag. Okay, now when you pull a marble, you're going to keep that marble. So if we keep them, because it's going to match the last problem, we are going to have only 2 marbles in the bag now. So the probability is going to be 1 times 1, 3 times 2. So that's going to be a probability of 1/6, which shouldn't reduce. 1 divided by 6, math, make it a fraction. It stays 1/6. As a decimal times 100, our percentage is 16.7%. Okay, so the probability that Mr. Fogarasi will have Maggie pick a blue marble followed by Daisy picking a green marble, okay, if each student is picking a marble, is 1 out of 6 or 16.7%. Okay, if you have any questions on any of these last problems from this review or any of the reviews, make sure you are asking your teacher either during sync time, during tutoring time, or if you're an in-person learner, during class. All right, thank you so much for watching.